Very good evening to all of you. Welcome you guys. Welcome you all of you. Good evening all of you. I hope I'm audible. Is audio video is clear? You tell me first of all. Very good evening to all of you. Welcome you guys. Good evening all of you. Welcome you all. Welcome you guys. So welcome to the Unacademy, India's largest online education platform, guiding the number of students to achieve the dreams of many students. Right. Now you can see now here this Unacademy is providing a great offer to you all of you, that is Unbox 2022. With this, by taking the 1 year of subscriptions, you will get additionally 6 months additional subscription आपको मिलने वाला. That means by taking the 1 year subscription, you will get 6 months additionally, and 18 months you will get another 6 months. 24 months you will get 6 months. That means 1 month and above, whoever the fellows will take this 1 year and above, those fellows will get additionally 6 months additional extension आपको मिलने वाला. It is a really great opportunity to all of you. And don't miss this opportunity. Try to utilize this opportunity as soon as possible. And the offer is valid only up to June 15th only. That is for tomorrow. Up to tomorrow. Tomorrow is the last date. So try to utilize these opportunities. Right. Hello. Next. And you can plan this Unacademy subscription by with a no cost EMI. You can plan it with a no cost EMI without paying any additional charges. You can get it. EMI options. And these are the benefits of one-to-one live mentorships. By taking 6 months, you will get additionally 12 sessions आपको मिलने वाला. 9 months 18 sessions, 12 months 24 sessions, 18 months 36, and 24 months 48 sessions. You will get it. And you can use this code of BV Reddy to avail these opportunities. Right, the special class features. So here we are continuously doing the 1 day YouTube session. The another day we are doing the special classes. And today we have a YouTube session. Tomorrow we have a special class. The next special class is on, that is 15th. 15. So in the special class, the timings are same timings. 7 p.m. In the special classes, we are discussing the network theorem problems we are discussing. Network theorem, the most expected questions for the GATE 2023, we are going to discuss on the network theorems. Fine. Next, you can get the daily scholarship test. Those who are not able to pay this subscription and all, you can take the daily scholarship is available. The top one ranker from each branch will get 50% scholarship. You will get it. So here 30% scholarship, 15% and 10% discount आपको मिलने. It's a great opportunity to all of you. And you can practice all the PYQs with the Unacademy PYQ series. Right. And the features of this Unacademy community, you can get regular updates from the educators. Notes, DPP, important notes, exam tips and tricks, you will get it. Preparation talks and motivational messages. And you can have you do follow my community regularly. I need to update the informations. Right. And these are the new batches we are starting here. Yes, 2023 here, 15th June onward, the new batch is starting. That is a batch D, and the subjects are keep on we are running here. You can see the top educators of India you can find. And you can see now here the 2024 batch, 2 years batch it is a, you can find the top educators in single frame. And so here this is 2023 target ESC, GATE and ESC 2023 batch. And you can see the educators, the top educators of India you can find. And you can find here this is GATE 2022 top rankers. GATE 2022 top rankers. And one more thing here. And so in plus course, I'm going to start the digital. I'm going to start digital. The course is commencing from 29th June. 29th June onwards, we are starting digital. And we are going to start the signals and systems also. That is from the July 13th onwards. July 13th onwards, we are going to start. Okay, they are the new courses from me coming from here. Digital as well as signals is going to come. And the digital course, the timings, we can say it is that is 3:45 p.m. And the signals course, the timings are 10:45 a.m. Okay, so you can enjoy the two subjects parallelly will be run, right? And these are the toppers from the ESC from Unacademy team, right? And with this Unacademy subscription, you will get with the plus course, you will get top educators, doubt solving, study notes, and test series milega. And in addition to this, with the iconics, you will get additional benefits of physical notes, one-to-one mentorship, study and strategy programs, interaction with the educators. Okay, these are the features you can see. Now, let's start our discussion here. Now, how many problems we have completed in the assignments, you tell me? How many problems we have completed in this assignment series? All of you do comment it. So how many problems we have finished in the earlier, this is the second class on transient now. 14 problems we have finished, right? Right, 14 completed. Next, take the next problem, 15th one. 15th one. I hope all of you are comfortable with this audio and video. I hope all of you are comfortable audio, video, and this as a thickness of pen size also, isn't it? Now, chaliye, let's start our discussions. See the problem here. For a second order system, the damping ratio zeta given as 0 to 1, then the roots of the characteristic polynomial are. So here, the zeta, which is given as what you tell me now here, which lies between 0 to 1. That means what we can say this type of system is a, what I should call this type of system is now here. So which is a underdamped system, which is called as a underdamped system. If it is underdamped system, then how the voltage or current in general expressions x of t, if I say, which will be in the form of e power minus at into what we can say here, which is in the form of sine of omega t plus theta. Like this we have now the response of the system, it should be like this. For these cases, now tell me how the roots must be, tell me. Roots which will be in the form of alpha plus or minus j beta we need to have now. Alpha plus or minus j beta form, isn't it? Alpha plus or minus j beta. How the roots must be here? Those must be in a complex and conjugate. Now tell me. Complex and conjugate. Then only we'll get the expression. Now tell me. If we have the roots are like this, what is the expression you tell me? We have seen in the maths we used to see, that is x of t, which is given as, if we have the roots like this, e power minus alpha t into what we can say here, c1 into cos beta t plus c2 into sin beta t, and of course which we used to convert this thing as x of t, we can convert, which will be in the form of e power minus alpha t into, that is sine of, yes, something omega t plus theta something, we can convert it, isn't it? So that how the roots must be here, the roots must be complex conjugate होना पड़ेगा. Done. Next, and take the next problem. For the circuit shown, different time constants are given. What are the charging and discharging times? Charging time constant and discharging time constant they are asking, right? What will be the charging time constant and discharging time constant? Charging. Now tell me now here. So this is for t less than 0, for t less than 0, the switch is at position 1. At t less than 0, the switch is at position. So here we can say at this location, let us call this is the position 1 and I am calling this is a position 2. For t less than 0, the switch is at position 1. If the switch is at position 1, so what happens to the capacitor? Capacitor will get charged. So which we can call this as a charging time constant. Then we can find the charging time, we can find now. Charging time constant. Find out the charging time constant when switch is at position 1. When the switch is at position 1. So which is connected, tau. Tau which will be given as what we can say now here, RC. Tau is given as what? R equivalent into C equivalent. So how much the tau value, tell me here, charging time constant. So here 5k and 1k, these two are series, which will be a 6k, 6 into 10 power minus 3 into capacitance value, which is equal to how much this value? 0.5 into 10 power minus 6. How much you will get the time constant, you tell me? Which is equal to 3 milliseconds now. This is the charging. Next, for t greater than 0, yes, which is at position 2. For t greater than 0, which is at position 2. Then now in this case, we don't have any source in the network. So we can say it is a discharging time constant, we can say. Discharging time constant. Tell me now, discharging time constant means which is at position 2. Tell me how much the discharging time constant here. So these two capacitors are in series, which will becomes 1 micro. That is resistance value 10 power 3 into how much now here? 1 into 10 power minus 6. So how much the discharging time constant, you tell me? Which is equal to 1 millisecond. And so what's the option, you tell me here? So what's the option here? Sorry, how much is value? How much is value? See how much the C equivalent, tell me first of all. Oh, these two are series now here. Sorry, the capacitors are in series, right? What should be now here? So this is 0.25 into 10 power minus 6 into 10 cube. So how much the time constant, you tell me? Which is equal to 4 milliseconds, isn't it? How much this value? 4 milliseconds. Done. So what's the option now here? Option D. Option D, right? Next problem. A rectangular pulse of magnitude V and duration T is applied to a series combination of RC network. Series combination of RC. The need of time constant. So what is a, it is not a need of time constant. What is the time constant? The time constant means the time taken to pick up, to start. Yes, simple example, the best example, what we used to call here. Let us say here, you are starting your vehicle. You are starting your vehicle. So now when you're starting your vehicle, so that means what now here? To reach us to certain speed now here, it will take some time, isn't it? The pickup time, that is called as like a time constant. The pickup time, that is called as a time constant. So what is a time constant? What is the need? So here this is always we have any system will takes to reach to the minimum. So here 30% of this maximum value to reach some time. That time is called as a time constant. Okay. Now here he applied this as a rectangular pulse. He given this as a rectangular pulse has been given. Saying this as some rectangular pulse. He applied. Right now here this is time axis. If I say the rectangular pulse, a duration, pulse duration which is given as a t, this thing like this, a pulse duration. So here having this amplitude is a v, so this is v of t we applied. Right now what they're saying here is, the video is clear to all of you? Tell me first of all, are you facing any problem, any issue in the, is the image, is that image is clear to you? Any problem you are facing? Hmm? Clear only, na? Clear only? No, there's no problem, right? So fine. I'm finding little blur. It is blur I'm seeing here in the mobile. Blur I'm seeing in my mobile. That's why I'm asking. Okay, right. Now this is the pulse he applied to a what circuit? To tell me now here? RC circuit he applied. This is the voltage he applied. This is my V of t, right? And this is R and C. I can say now switch has been closed at t is equal to 0. At t is equal to 0 onwards, we have start supplying the energy. Now tell me, we have start giving the energy. As t is equal to 0 onwards, right? Now he is asking the maximum voltage developed across the capacitor. He is asking. Now you tell me now here, let us find the voltage expression across the capacitor, that is Vc of t. Tell me what we can say Vc of t, voltage across capacitor. We can say Vc of t. So we need to find Vc of t, right? Now, so tell me now here, Vc of 0 minus, how much this value which is equal to 0? Vc of infinity, Vc of infinity. How much this value? Total voltage V now here. Now, so we can write the expression for Vc of t. Tell me here. So Vc of t, which is given as final value plus initial minus final into e power minus t by tau. Minus t by tau. Tau equal to RC. This is the expression here. Vc of t expression. Now, can you tell me now when it will be a maximum? You tell me. When this value is maximum. Now here you see this thing up to from we are applying the energy here. From here to here we are applying a maximum energy, isn't it? Beyond that, so there is no energy is applied now here. So this could be maximum. I can say now here we'll get at t is equal to capital T. At this instant only it could be a maximum. Yes, at this location. This is the expression we have seen. This is what now? 0 less than. Yes, this is the expression we have seen now here, isn't it? Now, when this will be maximum, you tell me. When this will be maximum. After that, it will decrease now here. At t is equal to 0 is a maximum. So, what happens now here? Vc of t, which will be maximum. This maximum value when t is equal to capital T, V into that is 1 minus e power minus capital T by RC. Now, even if you want to draw this thing here, how this waveform, so then how should be now if we can draw this waveform now here, the variations. Now, this is a T, the variation, how it should be now here. So, slowly it will rises, it will reaches to the high value. At this location, let us consider here. Next, after reaching here, then this value will be false. Will decrease like that. Isn't it, everybody? Now here it is a maximum value. Okay, all of you. Here next problem. Next, tell me now here. An ideal voltage source will charge an ideal capacitor. Ideal voltage source will charge ideal capacitor. Yeah, tell me this thing, all of you. Ideal voltage source will charge ideal capacitor. Ideal voltage source. Ideal voltage source. How should be now here? What is the internal resistance of an ideal voltage source? Said V of infinity is 0, yeah. So here that is infinite means what, a long time after the transient state, isn't it? Right. So here V of infinity, what's the meaning of this is when it is reaches to steady state. You try to understand here what the meaning of V of infinity means. It is when it is reaches to steady state, that is called as a V of infinity. Now you see this thing here at t is equal to 5 tau. How much this value, this expression? When, so here when t value is equal to infinity, when the t is equal to infinity, what happens? Tell me how much this value, tell me. As t is equal to infinity, this value completely becoming 0 or not? What's the meaning of t is equal to infinity? Means a long time after the steady state at the 5 tau time constants, right? Now you tell me now ideal voltage source they given. Ideal voltage source means what you tell me now here, having an internal resistance is 0 and capacitor also does not have any internal resistance now. That means how much the time constant we can say now here, tau is equal to RC, isn't it? Which is equal to 0. So it can charge instantaneously, isn't it? It will charge the capacitor instantaneously without any time. Almost 0 time it will charge it. Next, energy stored in a capacitor over a cycle. Energy stored in a capacitor over a cycle. Over a cycle. What's the meaning of one cycle? One cycle, AC signal. It should be one complete cycle. This is one complete cycle, isn't it? This is one complete cycle, which we can say positive cycle, and this I can say this as a negative cycle, negative part, right? So during the positive cycle, what happens now here? Yes, what happens now? Capacitor will charge. Capacitor charge. And the negative cycle, what happens to capacitor will discharge. It will discharge. As a result, what is the net energy over a one cycle? Tell me. What is the net energy over one cycle? How much it is? Tell me. The net energy, which is equal to what? Yes, 0. So the net energy, which is equal to 0. Everybody, is it clear now? But so here is the screen is clear, but in my mobile it is not clear here. Are you able to see the problems are clearly? In my mobile it is not showing properly. Fine. No problem now. Tell me all of you, no issue. Able to read the problem carefully. It is not appearing properly. Okay. Fine. Next. And instead of next problem. Okay. Leave it. Okay then carry on. Two coils having equal resistance. Two coils having equal resistance but different inductances are connected in series. Two coils having equal resistance and different inductances are connected in series. The time constant of the series combination is, then what will be its time constant? I have two coils. The two coils having equal resistance. Now this is R. Let us call this is my L1. I have one more coil. And this is L2. Right. Now for this, can you find the time constant? First one here. Tau1, which is given as what we can write now here, L1 by R. Now the time constant tau2, which is given as what we can say here, L2 by R. Right. The time constant of series combination. Now these two are connected in series. Now these two they connected in series. When they connected in series, can you tell me the overall time constant now here? Which is given as L equivalent by R. L equivalent by R. Tell me how much this time constant, you tell me L equivalent, which is given as L1 plus L2. Isn't it? L1 plus L2 by R. R equivalent, which is given as 2R. So the time constant which is given as, all of you do comment your options, which is equal to 1 by 2 into, which is equal to L1 by R plus L2 by R. So that time constant tau, which could be given as what we can say here, 1 by 2 into what we can say here, tau 1 plus tau 2. Check this thing, all of you, which is equal to tau 1 plus tau 2. So what we can say, this is nothing but what we can call now here, it is nothing but average of the time constants, average of the two time constants, right? Next, see the next problem. An inductor at t is equal to 0 with initial current I0. An inductor at t is equal to 0 with initial current I0. So tell me how the inductor will behave, so tell me. What is the equivalent circuit of inductor? Inductor will have a parallel initial current. Inductor will have what you tell me now, equivalent circuit is a, it has a parallel initial current, right? L and this I0, right? This is general. Now you tell me now here at t is equal to 0, at t is equal to 0 plus, immediately after switching action, which is nothing but transient state now, which is nothing but transient state. In transient state, how the inductor will behave, you tell me? Inductor will behave as a open circuit. That means the equivalent circuit at t is equal to 0 plus. It should be what you tell me now here. This is I0. At t is equal to 0 plus, what happens now here? This is open circuit now. So I can say it is simply behaves like what you tell me now here. It will behaving like a current source. Then chalo next problem. Right, tell me the next problem. An inductor carries a steady state current of I0. Okay. Now suddenly at t is equal to 0, initial current is given as I0. Suddenly at t is equal to 0, the inductor is removed from the circuit. Inductor is removed from the circuit and connected to a resistor R. So the current through the inductor at t is equal to 0 is. So now can you tell me now here initial current, that is IL of 0 minus, which is equal to what you tell me now here I0. Can you tell me IL of infinity? So there is no source now here, which will be at 0. So can you tell me now here IL of t, directly we can write now here, which is equal to final value 0. We have only initial value only. There is a source free circuit, e power minus t by tau. So tau is equal to what we can say, L by R. Okay. Next one. The transient current in a circuit results from, transient current in a circuit results from what? Why we have a transient in the network? Indirectly they are asking what is the reason of a transient here? Because voltage applied, isn't it? impedance of the circuit, and changes in the stored energy in the inductor and capacitor. Yes. So why we have a transient? The transients in the network is because of what now here? See, variation of the energy in the inductor and capacitors. Okay, because sudden variations we have a transients will occur, right? Next, and take the next problem. A two-terminal black box contains one of the element, either a resistor, inductor, or capacitor. It will contain either resistor, inductor, or capacitor. The black box is connected to a 200 volts AC supply. Black box is connected to a 200 volts AC supply. The current through the source is I. When the capacitance of zero point 0.1 farad is inserted in series between the source and the box, the current through the source is 2I. Then the element inside the box is. Understood the problem here? Is the font size is clear now to all of you? Tell me first of all. I have a box. This is network. In this box we have only one element only, either resistor, inductor, capacitor. We have only one element. When it is connected to a supply, how much the supply is connected? You tell me here. 220 volts AC supply. He connected to a 220 volts AC. He connected. Now, when he is connected, this current he given this as a I. If I call this network having some impedance of Z, so what I can say now, Z is equal to Z value we don't know, some impedance. Now from this, can you get the value of current? From this, if I say I is my current, which is given as what we can say here, 220 by Z, isn't it? Now, when a capacitor is connected for the same network, he has connected a capacitor in series. In series, when he connected, can you tell me I in this situation? Can you tell me here we have the current is increases, isn't it? We have the for the same network. I have connected one capacitor. I have connected here. Now the current increases. So how much this is a 0.1 farad we have connected, right? So same supply 220 volts. Now here this current they are saying it is a 2I magnitude of current. Now in this situation, can you tell me the impedance of this network? Overall impedance I am saying here, which will be given as, what is overall impedance now here will be added now. So will this impedance could be added now here? As a result, this current which is given as a 2I, which is equal to 220 by, what should be now here? This is Z minus, which we can say here, J. Yes, now here. So this capacitance value. So let's convert the capacitance into ohms now here. How much is this value? Tell me. Which is equal to 1 by omega into zero point 0.1. Right. So it will becomes what now here it is a Z minus J 10J by omega. Check it all of you. Then this is my effective impedance now. Here we already know I is equal to 220 by Z. So from this 220 by Z into 2, which is given as what we can say here, 220 by Z minus J10 by omega. Can you simplify this thing here? Tell me. So this is 2Z minus J20 by omega. J20 by omega. Isn't it? Is equal to Z. So from this, what we can say now here, Z is equal to how much, you tell me? Which is equal to J20 by omega. This is the impedance of what, you tell me? What is this thing? This is the impedance of the element present inside the box. Isn't it? This is the impedance of the element present inside the box. So can you tell me now here from this, can you identify the what might be the element is it? It is an inductive or capacitive element. What might be the element is it? So here if it is an inductor impedance form which is given as j omega L. For capacitor what form it is a minus j by omega c. These are the forms for capacitor and this is for inductor. Reactance you can see now plus j. Reactance which we got it as a plus j we got. If the reactance is positive, that means what we can say, the type of element, you tell me? Since the reactance is positive, so what I should call the type of element is a inductor. All of you tell me this thing. Everybody, is this thing clear to all of you? Hmm? Omega denominator, that is because of the value will come now. Omega denominator, that is because of the omega, you can decide the value, how much it is. That will give the magnitude only will gives. Okay. This term will gives only the magnitude only will gives. Okay. Omega denominator, it doesn't matter. That not affect. This is only magnitude only. So 20 by omega, this omega is the denominator, it will give only magnitude only. Okay. So we need to see the reactance, we need to see plus j minus j. Plus j minus j, we need to see it. Plus j minus j, reactance is positive or negative, we need to see. Based upon the reactance only, we can decide whether it is an inductor or capacitor. Isn't it? All of you tell me. Then, shall we move to the next one? Right. Now, a two-terminal box contains a single element which can be R, L, C, or M, where M is a mutual inductance. As soon as the box is connected to a DC voltage source, a finite non-zero current, is observed to flow through the element. Then the element is right. PDF, so I need to share this as PDF separately. I will share it separately. Don't worry. In the community, I will share it. Okay. In the WhatsApp group communities, I will share it. A two-terminal box contains one of the element. Now, R, L, C if it contains. Now, for example, if it contains If we apply DC source, what happens? You tell me here. Let us consider a simple example here. If we consider DC source, as soon as the box is connected to DC voltage, now tell me, I will connect only one element. One by one element we will consider first. If you have connected this as a resistor, when you connect now here, there will be some finite current will flow now. In this case, I value non-zero. If you have connected the supply DC supply to a inductor, if you connect, what happens? You tell me now here. Immediately after connecting, so what happens now? Inductor for DC case, inductor which is a j omega L, that means this value which is equal to 0 ohms na, that means which will be maximum current will flows or not, is a infinite. They mentioned it is a finite current. Finite current will flow. And capacitance, if we connect, what happens? You tell me. If we connect the capacitance case, then what happens? You tell me here. Capacitance case, which is 1 by j omega c. Yes, which will be infinite impedance. Then the current will become 0. Then the current will become 0. So same property for mutual inductance also now. Which case we have non-zero current will flow? Tell me. Only for the resistor case there is a non-zero flow of current. Isn't it? Next. If an RLC circuit having phase angle phi E is switched when the applied sinusoidal voltage wave is passing through an angle theta. Okay, the switch is operated at t is equal to 0, then there will be no switching transient. That means to avoid the transient, under what condition we can avoid the transient? So first of all, understand the problem here. So here the switch is operated at t is equal to 0, right? Switch is operated at t is equal to 0. We have resistor and inductor, DC supply, sinusoidal voltage source. Sorry, he is not DC supply. He is a what supply? He is a sinusoidal supply. That is V of t. So here assuming this as V of t, which will be given as, which is equal to Vm into sine omega t plus theta. Sine omega t plus theta. Now tell me now here under what condition there is no transient here for the transient free response. Transient free response, as we know, for the condition, tell me. Transient free response, the condition is for sine wave now here this is omega t naught plus theta, which is equal to 5, tell me, since it is a sine harmonic. Now the switch is operated t is equal to 0, that means what we can say t naught which is equal to 0 plus theta, that must be equal to phi now, that is theta. Phi is equal to what, you tell me? That is a phase angle of the network, that is tan of omega L by R. Isn't it? Under this condition, if the switch is operated at this condition, there is no transient. So, kaun sa option, tell me, which is called as a transient free response? Tell me, all of you. Next. Next, take this thing here. The correct sequence or time constants of the circuit shown in the increasing order. Time constants are in the increasing order they are asking. Now let us find the time constant of each one. Now here the time constant tau, if I say here, tau 1 if I call, okay, which is nothing but L by R. Now here the time constant tau 2 here, which is given as L by R by 2. So it will become 2L by R. Check it. And here the time constant, which will be given as what we can say here, L by 2, L by 2 will become L by 4 now parallel. So what happens, you tell me now here, L by 4, how much is value here, which is L by 2R will come now, tell me, 1 2 will get cancelled. This is my tau 3 here, which is nothing but L by 2 by 2R. This is L by 4, isn't it? So consa option he is asking to find increasing order. Ascending order we want. Ascending order means first one is 2 na. First one here. This is high. This is first. Sorry. Ascending order na here. So one by one here. Fourth one is first na, tell me. Fourth one 4. Consa option hoga, tell me C. Fourth one, third one, 1 and 2. Isn't it? All of you tell me, everybody. C is the option. Next. Now, in a circuit, the voltage across an element is given as like this. The circuit is, what we can do? Circuit on what factor, based upon what we can decide the nature of a circuit, to tell me, based upon the zeta response. Okay, they given the V of t is given, V of t, which is given as 10 into, I can multiply here directly. We have multiplied, yes, 10t minus what we can say here, 0.1 into e power minus 100t. This 100t for whole thing, no? 10t into e power minus 100t minus 0.1 into e power minus 100t. Theta we need to find out. For this, we have taken a Laplace transform V of s, which is given as, can you tell me the Laplace transform of this thing here, which is a t into this thing here? We can apply the first shifting property, so which could be given as, what we can say here, this is 10 by, what we'll get now here, t Laplace transform is 1 by s, which is equal to s plus 100 whole square minus 0.1 by s plus 100. First of all, you tell me now, this thing is clear to all of you? Is this thing is clear to all of you? Tell me. Any doubt? Laplace transform of t, Laplace transform of t, which is equal to t 1 by s square. Yes, 1 by s square, and e power at into t, Laplace transform, which is given as 1 by s minus a, 1 by s minus a whole square, shifting property, e power minus at into t, which is given as 1 by s plus a whole square. All of you tell me this thing. Done? So now we need to find the zeta. Simplify this equation here. Taking LCM, that is, so here s plus 100 whole square which is equal to, this is 10s plus 1000, yes, and here this is equal to, this is 1, this is 1 minus, what we'll get now here, this is 0.1 s, isn't it, minus 10. So we'll focus about only the denominator part, isn't it? So denominator part, if we see this thing here, second order system, this is, which is given as s plus 100 whole square. S plus 100 whole square means, can you tell me here, s plus 100 whole square, can you tell me the zeta of this thing here? So this is s square plus 2ab, what we'll get now here, which is equal to 200. What here, zeta 10 होगा 1k s square plus 200, yes, plus 100 square, isn't it? Is 10. Okay. Okay, so denominator we are not seeing now here. So tell me now, obviously here, this is the second order equation. So this is, which is given as s square plus 2 zeta omega ns plus omega n square, which is equal to 0. So this is omega n, which is equal to 100, and the 2 zeta omega n, which is equal to 200. By comparison, we can say zeta value, how much you tell me now, 1 na? If zeta equal to 1, the response, which we can call this as a critical damping. If zeta equal to 1, we can call this as a, and the numerator part, it does not affect, isn't it? We don't have any effect of this numerator part. The response will depends upon only on the poles of a system. It is independent of the zeros. Okay, all of you tell me. In zeta equal to 1, which is a critical damping. Right. Next. A unit step voltage is applied at T is equal to 0 to a series RL circuit with zero initial conditions. With zero initial conditions. Then what? Unit step voltage which is applied at T is equal to 0 to RL circuit. Then tell me now, initially zero conditions. इसका मतलब क्या है? IL of 0 minus, which is given as 0, isn't it? So that's why IL of 0 plus, which is also equal to 0. These are initial conditions given. Next, what happens now here? At T is equal to 0, they connected. It is possible for the current to be oscillatory, isn't it? So, is it possible to be the current to be oscillatory response? No. They apply U of T applied, right? And this is my R and L. Next, voltage across resistor at T is equal to 0 plus E 0. Now this is a series combination. So here tell me now at T is equal to 0 plus, how much the current in this network, you tell me at T is equal to 0 plus, current is 0. Then whatever the voltage across this resistor, you tell me at T is equal to 0 plus. Yes, which is equal to 0 volts. The energy stored in the inductor in the steady state is 0. No. So we have energy stored is non-zero now here. We have source is present or not. If the source is present, how it is energy is 0? It is non-zero. the resistor current eventually falls to 0. Resistor current will increases, not falls to 0, isn't it? Resistor current increases. Done? Chalo, next one. A 1 microfarad capacitor is charged through 2K resistor by 10 volt source. The initial growth of the capacitor will be at the rate. Initial growth of the capacitor. So here you may have a doubt here what we need to find. Initial growth of a capacitor voltage at the rate of. If you observe carefully the options you can see now here. Volt per second form is high na. The options you can see now volts per second. That means can you identify what we need to find here? Then I can say this as dVc of t by dt, isn't it? And initially means we can say t is equal to 0 plus. Yes or no? He indirectly asked him to find this thing. Now here, see the connection here. We have 10 volts DC supply. We have a combination of resistor and the capacitor is present. Resistor which is equal to 2K and capacitor which is equal to 2 microfarads. Initial growth they are asking at t is equal to 0 switch has been connected. Okay, t is equal to 0 only switch has been connected. Now tell me what we can do here. Let us find the expression here. Initial values. Can you tell me now Vc of 0 minus is equal to 0. Next Vc of infinity which is equal to 10 volts. Now Vc of t. Tell me the Vc of t which is equal to final value plus initial minus final into e power minus t by tau. How much the tau value tell me? Tau is equal to 2 into 10 power 2 into 10 cube, right? So which will be equal to 500. Now tell me now here dVc of t by dt. So which will be given as minus 10 into 100 into e power minus 400t. Check it all of you. So which will be equal at t is equal to, they ask initial values, t is equal to 0. So what we can say now here, dVc of 0 plus by dt is equal to 5 into 10 cube. Isn't it? This is what you tell me now, volts per second. Here options are in the volts per milliseconds, right? So which we can modify in terms of milliseconds. dVc by dt which will be given as, that is 5 by 10 power minus 3 we can say now. Now it is volts per milliseconds. Now this is volts per second, isn't it? Now this will be given as 5, this is volts per milli, this is nothing but milliseconds. Okay, then all of you tell me. Fine. Yes, all of you do like the session immediately without any delay. All of you do like the sessions. And yeah, that's for the today's class. And tomorrow we have a special class on Unacademy at 7 p.m. Like this will continue the same manner daily. Okay. And that's for the today's session and we'll meet in tomorrow we'll meet. Okay then, see you. Bye-bye.